We're going to have a look today at equivalent fractions. So if two things are equivalent, that means they're the same. So you're writing fractions that are the same as other fractions, okay? So in the first one, it's asking for 3 equivalent fractions for a half. Now let's just draw a wee picture. So imagine I've got one whole unit. It's maybe not very well drawn. And there it is split in half. Okay, you're going to have to use your imaginations a bit because it's not a perfect circle and it's not perfectly cut in half. But you can see that we've got a half of it. Okay, now if I cut that again in 2, so I've got a half, but you can see there it's also 2 bits out of 4. Okay, and I could cut it in half, cut all these pieces into half again. Okay, and then I've got 4 bits out of 8. Okay, or I could have started off, I could have, here's another half. Oops. I could have cut each half into 3. Okay, 3 equal bits, and then it's the same as 3 out of 6. And these are all equivalent fractions, they're all the same. Okay, and it's like I'm multiplying. So here, it's like I'm multiplying my shaded part by 4. And I'm also multiplying the total number of pieces by 4. So to get that 4/8, it's like I've multiplied the numerator by 4. And I've also multiplied the denominator, the total number of pieces, by 4. Okay? When I'm going from a half to 2/4, it's like I'm multiplying the numerator by 2 and the denominator by 2. Because do you remember for that one, it's like I had, oh goodness me, let's start again. I had 1/2 and I'm cutting everything into 2 bits. So I've got my 1/2 split into 2 now, 2, and all 2 bits before are now split into double that is 4, okay? So all I'm doing to create these equivalent fractions is multiplying the numerator and denominator. And I'm multiplying them by the same thing, okay? So if I multiply the numerator by 2, I can't then multiply the denominator by 3. That's not going to give me an equivalent fraction, okay? So 3 equivalent fractions, I could multiply by 2, top and bottom, get 2/4. I could multiply by 3, top and bottom, and get 3/6. I could multiply by 10, top and bottom, and get 10/20. Okay, I can multiply by anything I want just by splitting all the pieces into however many bits I want. Okay, as long as they're the same number top and bottom. Okay, so for 3/4, I could, let's multiply it by 2 top and bottom and get 6/8. Or I could multiply by whatever you want, your favourite times table, okay, 5 times table, and get 15/20. I could multiply it by 100, do you know, any times table at all. As long as it's the same for the numerator and the same for the denominator, 300/400 there, okay. 5/7, same goes, I could multiply it by 10 and get 50/70. I could multiply it by 3 and get 15/21. Multiply by 7 and get 35/49. Whatever you want to multiply by, these are all the same fraction. Okay, so that's how you can find lots of equivalent fractions for one fraction. And that's really going to be the basis of a lot of the work we do on fractions. So it's really important to understand this.